This is a video on the curl of f and the divergence theorem. The question states, show that for any closed surface S, the surface integral over S of the curl of f dotted with n times ds is equal to 0. So let's start by writing down what the curl of a vector field f is. So remember, the curl of f is del cross f, which is the determinant of the matrix I, j, k, del over del x, del over del y, del over del z, m, n, p, where f is the vector field mi plus nj plus pk. And we're going to assume that m, n, and p all have second-order partial derivatives that are continuous. So let's work out this determinant. For the I component, I get p sub y minus n sub z. For the j component, I subtract, and what I'm subtracting is p sub x minus m sub z. And then I add the k component, and for the k component, I get n sub x minus m sub y. So now I want to use the divergence theorem because we have a closed surface. And to do that, I need to first calculate the divergence of our vector field, and in this case, the vector field is the curl of f. So I calculate the divergence of the curl of f. And that means I take the partial derivative with respect to x of the I component, and that's p sub xy minus n sub xz. And then I take the partial derivative with respect to y of the j component, and that's minus p sub yx, and then minus a negative or plus m sub yz. And then I take the partial derivative with respect to z of the k component, and that's n sub zx minus m sub zy. So now, because I'm assuming that the second order partial derivatives are all continuous, that means that the order at which we take the partial derivative doesn't matter. So that means p sub xy is equal to p sub yx, so that p sub xy minus p sub yx is equal to 0. So the p terms cancel. And also we have negative n sub xz plus n sub zx, and that's also equal to 0. And we have m sub yz minus m sub zy, and that's also equal to 0. So all of these terms cancel, and we get that the divergence of the curl of the vector field f is equal to 0. So now I can apply the divergence theorem, and that states that the surface integral over a closed surface S of a vector field dot n ds, and in this case our vector field is the curl of f, is equal to the triple integral over the enclosed solid of the divergence of that vector field, so the divergence of the curl of f dv. And the divergence of the curl of f was equal to 0. So we just have the triple integral over the solid of 0 dv. And the triple integral of 0 is just 0. So I can conclude that for any closed surface S, the surface integral over S of the curl of f dot n ds is equal to 0. And I'm done with the problem.